YouTuber was wondering if I'd do some more on logic gates, so I drew up a couple of ideas. One on the OR gate here, and this is the final idea that I had for an OR gate, and also an exclusive OR, and this is its final diagram that I came up with. You can see it's a little more complex. And here's a demo on these two circuits. Here's the OR gate. We can have A right here, or we can have B right here, and we can have both. The exclusive OR, we can have A, or B, but not both. Just one or the other. Here's the wiring diagram for the OR gate. And here I've applied power to the circuit, and both the transistors are open. They're not biased, so there's no current flow when A is 0 and B is 0. But when I applied a positive voltage to A, the result was the lights, or the LED lights. And when I took it off A and put it on B, the LED is lit again. Also, when I put an input on A and B, we still have an LED lit. Not too complicated of a circuit. We got two inputs, and you might think that, well, we could have used a wire. Well, that's true, but the two inputs would not be isolated from each other, and that can be important in some circuits. This is the wiring diagram for an exclusive OR, and here I have applied power to the circuit, and with no input at A or B, the bottom two transistors are wide open. However, the top two transistors are biased to conduct through those 10K ohm resistors that lead up to the positive side of the power supply. Now, when I put an input at A, the bottom left transistor at the collector shorts out the bias for the top right transistor, turning it off. But now we have a path on the left. Both of those transistors are biased to conduct, and we have our LED lit. Now when I take the signal off of A and put it on B, well, now the right bottom transistor is shorting out the bias for the upper transistor on the left. But we now have a path of current through the bottom right transistor and the upper right transistor, and the LED is lit. Now when I put a signal at A and B, the bottom two transistors short out the bias for the top two transistors, and they are turned off, so the result is the LED is not lit. Here's the OR gate. We can have A right here, or we can have B right here, and we can have both. The exclusive OR, we can have A, or B, but not both. Just one or the other. I hope this demonstration and the drawings helped you understand the OR gate and the exclusive OR gate a little better. Thanks for watching.